First, I want to clarify a couple things about Kramer's rule from my previous video. For one thing, it's only used on square matrices. Um, yeah, it's only used on square matrices, and you need to find the determinant of A first, really, because if it's zero, you don't have a solution. Secondly, when I did this example, I referred to columns as rows. I should have said replace column one over here with B, and over here replace column two of A with columns, not rows. Okay, this is the real point of this video. At this point, we've been through multiple methods to do multiple things. Finding the determinant, finding the inverse, and solving a system of equations. For the determinant, we could use Gaussian elimination and then properties, or we could do cofactor expansion. For an inverse, we could use that Gauss-Jordan elimination method on an augmented matrix, or you could use the adjoint method, which we more recently did. And solving a system of equations, you could use Gaussian elimination with back substitution, or you could go all the way with Gauss-Jordan elimination, or we just covered Kramer's rule, if it's square, A is square. Or you could find the inverse and find, if there is one, x equals A inverse B. So which ones should you use as a student? And which ones should computers use? Students, you're going to be usually given where the n is only 2 or 3. In fact, that was almost 100% of the problems I gave my students on either homework or exams. For small sizes, like n equals 2, it's just easier to remember those formulas. For the determinant, it's just that x formula, the product of the main diagonals minus the product of the off diagonals, that guy. And for the inverse, the determinant's the same thing as up here. And the adjoint part, you just switch the main diagonals and change the signs of the off diagonals. It's just easier to memorize that. What about 3, n equals 3, and bigger? Well, here's how many operations in general. Here's how many operations for 3 by 3. Remember, determinants and inverse only work on square matrices, and Kramer's rule only works on square matrices, as well as this guy. So most of what we're talking about is square matrices. Anyway, if you look at this, for the determinant, as a student, the most efficient thing is the cofactor expansion. And maybe that's all you were taught. I think that's all I taught in my NMath 8 course. For the inverse, the adjoint method is much better than Gauss-Jordan elimination. And that's the only method I taught in my NMath 8 class. And for solving AX equals B, let's see, what's the most efficient? Gaussian elimination with back substitution. And that's primarily what I taught in my NMath 8 class. But if you look for larger systems, and I'm not going to go through these numbers, Gaussian elimination, or elimination of some kind, was usually the most efficient way. And I believe that's how computers are programmed. So we use one method for computers and a different method for you students, because you're normally just doing 2 by 2s or 3 by 3s that you'll do in your subsequent courses. But really, the workhorse, when the computers do it, they're going to be using Gaussian elimination of some kind or other. And that ends chapter 4 of my course on linear algebra.